Hello everyone, welcome back. As we can see now, today we are going to discuss linear equation in two variables. So far you have been doing linear equation in one variable, how to solve for the unknown variable x. Before we begin with this chapter, we must know the meaning of variables and constant. Variable are those values which are not fixed. That is why we use the letters of the English alphabet to denote variables. They take different values under different circumstances. When I am talking about linear equation is an equation of degree 1 and derived from linear polynomial. In polynomials chapter, we have seen that a linear polynomial is one with degree 1. So, linear equation we will have variables with degree 1. And since we are dealing with linear equation in two variables, we will be using the Cartesian plane to represent the linear equation graphically. Had it been linear equation in one variable, we should have represented it in the form of a straight line. Now, to begin with the objectives, what we are going to learn in this chapter and why, we will be learning how to define the general form of a pair of linear equations in two variables. Now, since we are dealing with linear equation in two variables, and to solve those two variables, we need at least two equations. The number of equations required to solve the values of unknown variable is always equal to the number of variables. If we have one unknown variable, then we require only one equation to solve it. If we have two unknown variables, we require two equations to solve it. And since we will have two different equations, the graphical representation of those two equations will be a pair of straight lines. Solving the pair of linear equations graphically as well as algebraically, and conditions, when we are solving the equations graphically and algebraically, we'll see different conditions about the pair of straight lines formed, whether the pair of straight lines formed will be parallel, coincident or intersecting. Now, starting with an example, how to frame a pair of linear equations in two variables. Given the data, we have distance on one side and fare paid on the other side. So, two attributes are always represented using two variables. The distance travelled is 10 kilometers and the fare paid is rupees 115. When the distance covered is 15 kilometers, the fare paid is 165. Now, let the fixed minimum fare be rupees x. Let the fixed minimum fare be rupees x. So, whenever we are travelling by any conveyance, any means of communication, there is always a fixed cost irrespective of the distance travelled, and there is a variable cost which depends on per kilometer you travel. So, if x is my fixed cost and the variable cost is y, ordered pair, fixed minimum fare and fare per kilometer. So, the first equation formed will be x plus 10y. If x is the fixed cost and as I am travelling 10 kilometers, per kilometer I am paying rupees y. So, for 10 kilometers I will be paying rupees 10y, and after that the total fare will be rupees 100. From the next situation, so two different situation leads to two different equation. So, we have two pair of equations, x plus 10y equal to 115 and x plus 15y equal to 165. And if I write it in a general form, I will be coming to the general form of the linear equation later, writing all the values on the left hand side and putting the right hand side equal to 0. This is the general form of a pair of linear equation. So, the general form of a pair of linear equation in two variables x and y is given by a1x plus b1y plus c1 equal to 0, where a1, b1, c1 are all real numbers. Now, and the second pair of equations a2x b2y plus c2 is equal to 0. where again a2, b2 and c2 are real numbers. So given these two pair of linear equations, we'll be dealing with different situations, how to solve them graphically, how to solve them algebraically, and how to find the conditions of the whether the lines are parallel, intersecting or coincident.